Yeah, hello. Hello, Joseph.
Hello, sir. Good evening, sir.
Yeah, good evening. Can you hear me?
Yeah, I can hear you, sir.
Very good. Very good. Okay. Last week we began with numerical methods to solving systems of linear equation. Okay. And the very first method we looked at was the Gaussian elimination uh, technique. Okay. The Gaussian elimination technique. And we did mention last week that the objective in the Gaussian elimination technique is to first of all reduce to upper triangular matrix per what we did in class. Okay. Yeah, we also have the LU, okay, factorization approach and other methods. But here we're looking at how to reduce to upper triangular matrix and then to make use of backward substitution, okay, to solve the Gaussian elimination technique. So we did say, let me just zoom in. So we did say that the major task at hand, okay, the major task at hand in Gaussian elimination was to reduce the triangular matrix. Okay, we have to reduce the triangular matrix to an upper triangular matrix like we are seeing here. Okay, once we are done, then we can use the backward substitution to solve for it. And we said in doing so, what you do is you take the first row, okay, you take the very first row, and then you use that to reduce the second, okay, element in the second row, first column, as well as the element in the second row, third row, third column, okay? Now, the whole idea behind this is, you see, the normal equations, this equation would have been written as what? X plus what? 5y plus what? 7z, okay, equals to 20. And then we have 2x minus what? 3y plus 4 plus 4 z, 4z equals to what? Equals to 4. And then we have 3x plus y plus y minus 2z equals to what? Is equals to 9. Okay. If I ask you to solve the system of equation, okay, using elimination, then what you do is you take two rows at a time. You take two rows at a time. So for example, or let me say two equations at a time this time. Okay. So this is equation 1. This is equation 1, equation 2, and then this is equation 3. So what you do is you try to take two equations at a time. In solving, you would have done equation 2 minus what? 2 times of what? Equation what? Equation 1. Okay. Equation 2 minus 2 times of equation 1. So in doing so, that will give us, you see, this is equation 2. So 2x, that will be 2x. Just a minute. And push this up here. So that's, okay. So in doing so, we'll be having 2x, okay, the linear combination will give us 2x minus 2x minus 2x. Okay, minus 3y. Okay, minus what? 10y. Okay, because we are dealing with 2 times of row 1. Then plus what? Plus 4. Okay, 4z. Okay, 4z minus what? 14 sets. Okay, is equals to 4 minus, okay, 4 minus what? 40. Okay, this is how we would have solved it. Then in the second operation too, you take equation 1. So you take equation 1. Let me write this as equation. Okay, so equation 2. Then this is 2 times of what? Equation what? 1. Okay, so when you simplify, this will give us 0. This will give you negative 13 y. This will give you what? Negative 10 sets. And this will give us negative 36. Okay, then similarly, like I was saying, the next thing you do will be equation what? Equation 3 minus what? 3 times of what? Equation 1. Okay, the question is why 3 times of equation 1? Our objective is to eliminate what? X. Our objective is to eliminate X. Okay, because in the first combination we eliminated X, so we want to eliminate X in the next combination, so that we are left with 2 equations with 2 unknowns. Then we look for our y and z and then use backwards substitution to solve. Okay, good. So it's the same approach we are using here. It's the same approach we are using in the Gaussian elimination. So in Gaussian elimination, okay, instead of using this approach, that's a normal elimination technique. Okay, what you do is you are going to use row 1, just like we are doing minus row 2, equation 2 minus 2 times of equation 1. This time we are going to write the operation as what for this particular row. Okay, let me clean this side. Okay, so for this particular row here, okay, you're going to have what? Row 2. So this now is not in terms of equations, rather in terms of rows. So row 2 minus what? 2 times of what? Row 1. Okay, and it's the same combination we are doing here. It's going to be the same combination we did as in the equation form. Okay, it's going to be the same combination, the same operation in there. Then when we come here, it's going to be the same operation once again. So this time will be row 3 instead of equation 3. So row 3 minus what? 3 times of what? Row 1 instead of what? Equation 1. Okay, our objective is to what? To change this first element, which is the x, the coefficient of x, okay, to 0. In other words, we are eliminating what? The component of x. Okay, so that was that's a summary from last week's class. Okay, we saw some examples. Okay, so we looked at the steps and then we saw some example from last week. If there is any question from last week, you can ask before we proceed. If there is any question, any other question from last week, you may ask and then we'll proceed. Okay, it looks like we are fine. So then let me go on to where we left off, okay, with our very bad network last week. So I mentioned last week that, okay, the operations for a normal Gaussian elimination could differ, okay? The steps involved could differ, which means that we are not going to get a common procedure, a common algorithm, okay? And once that happens, it becomes difficult to write a computer program to do the calculation for us. Don't forget, I told you from the beginning that when it comes to systems of equation, okay, they represent real life processes, and sometimes the unknowns or the variables at hand, okay, will exceed 3 by 3. It can go as far as 10 by 10. Okay, so for a 10 by 10 system, if I ask you to find a solution for me, you are not now going to pick a pen and a book to solve. It's going to take us the whole day when you're, even if you're an expert. Okay, so hence the need for us to write, okay, algorithms which can be implemented on computers, okay, to do the numerical calculation for us. Okay, so that brings us to the second method which we began with last week, which is the pivotal, okay, Gaussian elimination. Okay, the pivotal Gaussian elimination. Okay, and like I introduced you to the method, okay, this is based on what? This formula, or what you call as equation, okay? This is based on this formula. So in the reduction process, you're going to make use of these standard formulas, okay, as you see here. And I'm sure you've noted the formulas too down. I sent it to you in the previous slide, okay? So we're going to make use of these formulas for the elimination. And then once you've made use of it, okay, so what this is saying is, let me just explain briefly, okay? So if you have a matrix A11, okay, A11, A12, A13, then we got B1 here, okay, we have B2, we have B3, then we got A21, A22, and then we have A23, okay, and then finally we have the last row, which is 31, A32, and then what? A33, okay, good. Our objective is to get an upper triangular matrix, which means every value under the leading diagonal should go to 0. So A21 should be 0, A31 should be 0, and then A32 should also go to what? Should also go to 0. Okay, but in doing so, like we said, you make use of the first pivot. In pivoting, you're going to make use of the first pivot, okay, which will help you to estimate what? Your multiplier, okay? And I also mentioned that the multiplier is always the leading coefficient in a row. So the multiplier for row 2 will be what? A21 over the pivot A11, okay? So when it comes to the multiplier for row 2, it will be A21, okay? A21 over the pivot, which is what? A11. That is the multiplier for this row. And then once you obtain the multiplier, okay, stays, you use that for the end, all the elements in what? In the row, okay? Or let me put it across the columns of that very row, okay? Good. The same way, the multiplier is just like multiplying row 1 by what? By 2 and subtracting from row 2, okay? That is what the multiplier does. That's the function of it. Then when it comes to row 3, you have to calculate another multiplier. The multiplier, like I said, is the leading coefficient. So that will be A31 over the pivot. The pivot remains what? A11. Okay. So A31 over what? A11. Okay. That will be the multiplier. Good. So per this formula, we are saying if I have to change, you see, this is Aij. So if I is 2, if I is 2 and J is 1, and I want the new value for A21, then the formula says still go and pick A21. Okay, the formula says Aij. Okay, minus, okay, minus what? I is 2. So A21 with the leading coefficient, A21 over what? J is what? 1. So it's going to be 1, 1 here. So A, okay, 1, 1 here. All over what? Sorry, over A11 times the value on top. J is 1. Okay, J is 1. So this is going to give us what? A11, which is going to be what? A11. Okay, and per the formula, if you look at it, this side is going to cancel out. A11 will cancel out A11, and then A21 minus A21 will be 0. Okay, that is how you get your what? Your 0 as a new, okay, value in the reduction. Okay, so with this understanding, let's move on to an example. Okay, so we have the system here. We're supposed to use the Gaussian elimination, okay, to find a solution to the system. So first you have to write it in an augmented form as we are aware, and then next we reduce to an upper triangular matrix. Okay, and then once we achieve that, we use the backward substitution to find solution to the system of linear equation. Now let's go on to the solution. Yeah, so this is the augmented matrix form. Okay, we have the augmented matrix of the system. Okay, and then per our formula, per the formula, we are told that, okay, to convert the first element here to 0. Okay, if it was in the equation form, then it means we are eliminating 2. Okay, 2x. So to do that, we make use of the formula, okay, which we had. So that is going to be what? You pick the same element, which is what? A21 minus the multiplier, will be the leading coefficient of the row, which is 2, over the pivot, which is what? 1. So that is 2 over 1, okay, times the value on top, that's Aij, okay, A1j, which is going to be what? 1, okay, yeah. And then once we do that calculation, this will be 2 minus what? Minus 2, which is equal to 0. So that gives us the first 0 in this second matrix. Okay, let's do the computation for the remaining elements in the row. Okay, good. Okay. Yeah, so for A22, you have what? -3, okay, minus, you see, like I told you, the multiplier remains throughout the row, okay, operation throughout the columns of the same row. So -3, this is it. To reduce this, it's going to be -3 minus 2/1 times, that's A1J. So that's the value on top of it, which is what, 5. Okay, good. So once you do that, -3 minus what? Minus 10. Okay, -3 minus 3 minus 10, which is equals to what? -13. Okay, as you see above. Then you do same for the next element. A23 will be what? 4. So A23, let me clear that and move on. So A23 is going to be what? 4 minus 2/1 times 7. Okay. And then once you do that calculation, that will be 4 minus 2/1. That's 2 times 7 will be 14. So 4 minus 14 will be what? -10. Then finally, we come to B. Okay. So it's going to be the same. That's 4 minus 2/1 times 20. Okay. That should give us 4 minus 20 minus 40, which gives us -36. Okay, so that is for the first operation here. And the result is written in the next matrix. So we have 0, -13, -10, and then -36. Okay, now let's go to the next row. We're going to use the same formula. Okay, so just follow carefully. Maybe you want to do the calculation for the first one. Okay, so that will be what? 3 minus what? New multiply. We are on a new row, so new multiply will be what? 3/1. Okay, times the value in the pivoting row on top of it is 1. Okay, good. And that will be 3 minus 3, which is equal to 0. Then next we have what? Next we have 1 minus same multiply 3/1 times what? The value on top here is what? Is 5. Okay, so times 5. And then that will be 1 minus 15, which is -14. And then next we have A33 will be what? -2 minus 3/1 times 7. You do the calculation, that will be -2 minus 21, which is -23. And then finally we have 9. Okay, 9 minus 3/1 times 20. That will give us 9 minus 60, which is -51. Okay, good. So that gives us the next operation as well. Okay, so we got these values here. So you realize that we've succeeded in reducing all the elements in what? In column 1, okay, above the first pivot to what? To 0. So in the pivoting GU technique, we use the pivot to reduce all elements, okay, under the pivot to 0. Okay, which means that we're going to do same, okay, for this other element. And to do that, we're going to make use of the second pivot, which is what? -13 here. Okay, so we're going to use -13, which is in row 2, to reduce the -14 in row 3. Okay, good. So the question is, how do we do that? Same formula. Okay, the same formula. Okay, let's see how that is also going to work. Okay, because this is now the new leading coefficient. Okay, that will be, to get the multiply is going to be what? -14. And then this is the pivot, so it will be -14/13 for the multiplier. Okay, good. So let's see how this calculation is actually done. Yeah, so we have -14, okay, minus 14 over what? -13, okay. So you pick the elements minus the leading coefficient, which is what? Negative 14 over the pivot, which is negative 13, times the value on top of negative 14, which is what? Negative 13, which will give you 0. Then you do same for this one, you come and pick it. So that will be negative 23 minus the multiplier times the value on top of it. Okay, in the pivoting row, which will be negative 10. The same way, when you come here, you pick this value and the minus the multiplier times the value on top of it, which is negative 36. Okay, so let's see how it goes. Yeah, so that is it. So A33 will be negative 33 times the multiplier negative 14 times over negative 13 times negative 10, which will give you negative 159 over 13. Okay. Then finally we have B. Okay, new value for B, that will be negative 51 minus the multiplier times negative 36, and that should give us 159, negative 159 over 13. Okay, good. So once we have achieved, we've obtained our upper triangular matrix. Let me draw that again. Okay. So once we've obtained the upper triangular matrix, we can then rewrite the equations. Okay. We can rewrite it in equation form and use the backward substitution to solve for it, like you were seeing here. Okay, so we've eliminated x in the second equation and eliminated x and y in the third equation, which means we can easily find z from this equation to be what? Z equals to 1. Okay, and then substitute backwardly into the next equation to find y, and then you substitute y and z into the first equation to find what? To find x. Okay, now once again, let me mention, whilst you come up with any question that you have, okay, let me mention that the objective of this course is not to reduce the matrices into echelon form. Okay, this is not an algebra class. Our objective here is to find an algorithm. Okay, is to find an algorithm which we can implement, okay, using a computer software, solve any given dimension of linear systems. Okay, so at the end of this week's class, you'll be writing a program to that effect. So if you watch some of the videos on YouTube on how the Gaussian elimination technique is done, you will find that along the line, the concept of echelon forms, okay, are introduced. But we are not interested in obtaining echelon form of the system. We are interested in the algorithm, the process to solving the system. And then once we obtain the process, we can program. We shall program, let me put it that way, in class as an assignment. Okay, so now let me take some questions from you at this point. Let me take some questions from the class. Yes, Bright.
Sir, when you say program, do you mean in a specific language or like a general program?
Please come again.
You said you were going to be doing program.
Yeah.
So you said we're going to be looking at the algorithms and making a program. I'm asking whether it's going to be like in a specific language, like Java or C++, or is it going to be like a general program? like
So for now,
formats
we're
or?
going to make use of C++ and MATLAB. Okay. Since you've all been
Okay,
introduced
sir.
to C++, I think it should be advisable we use C++. And along the line, if we have time, I'll introduce you to the interface of MATLAB as well. Okay, which is also a very good programming tool for engineers.
Okay, sir.
Yeah.
Thanks.
Good. Yeah. Any other question? Edna?
No questions, sir.
Okay. Okay, fine. So I think the concept is clear to all of us. We want to try an example. So I'm going to give you a question to try in class and get back to me. Okay.
I want you to try this example.
Yeah. So write down the question, put it down, and then solve and get back to me. Okay. So you're using that's a partial pivoting Gaussian elimination method. Okay. You're using the pivoting Gaussian elimination method. Solve it for me. I'm waiting patiently. It will take a while, but once you get it for the first time, your confidence will be high. So solve it for me. I'm waiting for your solution.